in this session, we're going to just relook, just very quickly recap on the effective and the nominal interest rates, which were in the last section. What did we say there? We said nominal interest rate, right? Okay. The nominal interest rate, IM, and there's loads of ways that people do these, okay? I'm just using the one that I've got out of a textbook that we've used before. All right, the nominal rate is essentially the quoted rate, isn't it? So they tell you it's 8% per annum, all right, and they say compounded ... They're going to tell us how many periods they compounded. So what do I do next? The next one is the effective rate. Okay, the effective rate, just finishing off from the last one. The rate I'm going to put in here. This is the rate after adjusting for the number of compounding periods. And we're going to do a load of examples here. The number of compounding. This is called I effective. And what do we say? This is the formula. 1 plus I effective is equal to 1 plus I m over m to the power of m. That's pretty much where we left off. Now we're going to look. Let's look at an example, shall we? Where we can bring this together, because it's no use talking about it. Let's actually do it. Let's look at an example, okay? M, obviously, m over here. M equals the number of compounding periods, okay? So if it's per annum, it's once per year. If it's every 6 months, okay, that's going to give us the number of periods. But we'll see. Let's just go. An interest rate is quoted, okay? An interest rate is quoted as 8% per annum, compounded quarterly. Compounding quarterly, okay, or quarterly spelled out. Now, let's just think about what are we saying here? We are saying that in 1 year, I am going to add interest every quarter. What's a quarter of a year? 3 months. So in other words, I'm going to add interest once, twice, 3. There I'm going to do, there I'm going to do, there I'm going to add interest 4 times. You can work it out, okay? It's very, very basic. So therefore, m is going to be equal to 4. So I effective, okay, 1 plus I effective is equal to 1 plus nominal is 0.08. Remember, we put it as a decimal divided by 4 periods. 1, 2, 3, 4. If it was daily, we're going to do one now. It's 365 of them. Okay. Leap year, the bank gets a good time. So let's say that, and that's to the power 4. Now, here, guys, that must always be equal. Okay. That must be equal. So therefore, 1 plus I effective, is going to be equal to 1.0824. So therefore, I effective is 0.0824, which is 8.24%. Okay, that's what it's going to be. Okay, let's do the same example. All right, same example. Okay, but compounded monthly. What does it mean? Not monthly, compounded monthly. Yeah, well, this is maths, not English, but it's still going to be right. Compounded monthly. Hang on, what does that mean? It means at the end of every month, I'm adding interest. What does that mean? I'm how many times? 12 times. Therefore, I1 plus I effective is equal to 1 plus 0.08 over 12 to the power of 12. And you end up with an I effective over here, without working it all out, 8.3. Once again, please note, those are the same. All right. Now, let's see. How do we apply all of this lot? Let's go back to black, get another page going. Suppose we have, let's do another example here. Okay. Do this one with me. Write it down and let's follow it. Suppose we have an investment of and I've used 10,000 Rand, I think. You can use whatever you like, 10,000 euros, $10,000, 10,000 Hong Kong, 10,000, whatever you like. It doesn't matter. It's just a number with whatever currency you're using at the front, isn't it? Investment of 10,000, which is invested, okay, for 5 years at 9% per annum. Okay, at 9%, sorry, I just touched them, at 9% per annum, and compounded A, annually, B, semi-annually, C, yeah, okay, quarterly, D, I'm doing the whole gamut, aren't I? Monthly, and E, daily. Obviously the best one if you can get hold of it. Right, let's have a look. First of all, let's draw a timeline. My timeline says 5 years. So, 0, 1, 2, 3. So that's now 1, 2, 3, 4, and there's year 5. So what have I put in? This is now, remember, now I have put P equal to 10,000, and there's my currency. I put in here IM is equal to 9% compounded That's going to be the A, B, and the C, isn't it? Okay, so A, what do I do? Let's go through these one by one, right? We're just going to refer to the thing above. Annually, okay, annually, okay, A is equal to P1 plus I to the power of N, isn't it? Right, so let's have a look. A is equal to 10,000, 1 plus 0.09 over 1 to the power of 1 times 5. That's 5 years, and that's compounded once. Because it's annually. There, can you see? I'm going to do this every time. Okay, cancels out. Okay, not cancels out, comes to, they're the same thing. 15,386.24. Okay, that's straightforward, isn't it? But now we're going to change it up, and we're going to do it B, semi or semi-annually. What do? I say A is equal to P 1 plus I to the N. So P I know is going to be my 10,000. 1 plus I is 0.09. Whoops. 0.09. Divided by How many times am I compounding? Twice. To the power of 2 times 5. Once again, can you see? There it is. Right? It's, in other words, this is the effective rate, isn't it? Coming in here. It's compounded twice there to get the rate correct, and there's my years. All right? And that's going to give me an answer of 15,529.65. Okay, just check. I think I'm right. 0.69, I think. All right. I think, if my own handwriting is not deceiving me. Okay, C. C is quarterly. Quarterly. A is equal to P1 plus I to the N. But now I'm doing it quarterly, so my rate is changing because I'm quoted per annum compounded quarterly. Remember, I'm given the nominal rate. The nominal rate was my 9%, isn't it? 10,000, 1 plus, there it is. I have to adjust it 4 times to the power of 4 times 5, right? Which gives us what? Okay, let's just put in that number again. Okay, can you see? There it is, okay? This is once again the years, okay? And then we get that 15,656.81, okay? Right, and you can see that this is going to become exceptionally boring for you and for all of us. Let's go to daily. Oh, no, sorry, I've got to do monthly and then daily. Monthly is A is equal to, I'm going to put down here now, 10,000 times 1 plus nominal rate, adjusted 12 times 5. All right, and I'm going to highlight again. There we go. And that's the years there, isn't it? The 5. All right. My actual answer for this one is going to be 15,656. Whoops, hang on. Sorry, 15,605. Whoop, 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 whoop. My apologies. Thank you for correcting me. 15,605.09. This one is the 15,656.81. Last one, the daily interest rate. All right, here we are now saying daily, and I'm just going to do it straight off. 1 plus nominal rate is 0.09, isn't it? How many? 365 times. That's 365 times for 5 years. So how many times am I actually adding interest? Let's see. We add interest how many times? Well, at the end of each month, which means at the end of each day, so 365 times 5. So we added 365 times 5 equals 1,825 times we add interest. Okay, it's not a lot each time. The actual answer is 15,682.25. Okay, so now you say to me, okay, well, that's wonderful stuff. But, okay, is it real? Of course it's real. This is how the rates are quoted, isn't it? Banks quote it different countries have different rates. I mean, some countries' interest rates are very low. Some are very high. All right? Some, I'm told, are even negative at times, but that's not what we're looking at. Here we're saying to ourselves, this is how we actually operationalize this process. So when we're going through this, we've got an easy way through, an easy, great section of logic. Let's have a look at this example here. Okay. They say a car bought 5 years ago. A car bought 5 years ago is worth 55,250 today. Those of you who think cars are assets, think again. Okay, of course, sports cars, classic cars, things like that, of course they're assets, right? And if the car is depreciated, okay, at 5% per annum, compounded daily, calculate the original price. Typical question. Original price. All right. So we do a timeline, don't we? Okay. The original price, well, obviously of the car. So let's do a timeline. Okay. We're now going backwards, aren't we? We're actually saying, if you like, here's 5, 4, 3, 2, 1, and this is actually now. Okay? So they've told us the car now is 55,250. Okay? That's the amount. So therefore, if it goes back, hello, put a bit of logic here, the car price must have been higher. It must have gone down because it depreciated. Okay, for those of you who do accountancy, obviously. But just the logic inside us says that it is depreciated, okay, at a certain rate. So these are let's say minus. Okay, I'm hesitant to use minus, but this is going backwards. Okay, we do not count in minuses, so I'm rather going to take away. If you'll beg the indulgence here, I would rather not use a negative for time. All right? Goes against my physicist grain or engineering grain, but we don't use a negative for time because you then could be tempted to put -5 in for n, which is not the right way to do it. So let's have a look. Depreciate means decay, it's compound. So therefore, I is going to be equal to, well, let's just put in our numbers here. Okay. What have we got? Let's just move this up slightly. All right. Now, you've got it in front of you. It means decay, it's compounded. What is the nominal rate? Is equal to? It says 5%. All right? 5 divided by 100. Remember, that's step 1. So, therefore, we want A equals P, 1 minus I. Why am I using 1 minus I? Hey? Why am I using 1 minus? Because it's decay. Negative, remember? Okay, it's a negative. So I say A, I've got that. 55,250 is equal to P, which is what I'm after, isn't it? P was what it was worth a while back. And I say that's 1 minus 0.05, there's my interest, compounded how many times? There we go. The final thing is going to be P times 0.778787. Okay. Therefore, P comes out to be, you just divide through, right? 70,943.62. And that is where we've got that one. Let's just recap it. What did we say? Let's talk it through. We said we know the value today of the vehicle. What was the purchase price? And they've given us the depreciation. So this is obviously the current value on the books of a company, isn't it? It's what the company says the vehicle is worth today after it's been depreciated. So we're just working backwards. Can you see just the value of the timeline? And obviously there's a little bit of practice coming in, but essentially it's all just basic logic. There's no more, no less in these questions. Okay, let's have a look at another question on this, shall we? Let's have a look at this question. Example, we have got 100,000. Like, let's write an example here. Example. We have got 100,000 to invest for 2.5 years. Okay? For 2.5 years, 2.5 years, all right, at 10%, okay, compounded per annum, compounded semi-annually. All right? Semi-annually. Now, I want to trigger something here with you. Can you see that's telling me already I need to adjust the rate, right? If I go back up here, okay, it said compounded daily, which means adjust the rate, all right? So we're going to have to use the nominal and effective, all right? Let's just put in here then our little timeline, and we say now we've got 100,000, okay, and they want to know what do we get at the end, or whatever the situation is. Let's have a look. It's going to grow, and we're going to say it's over 2.5 years, okay, and calculate the amount. Okay, here we go. Okay, so I say amount is equal to P 1 plus I to the power of N. There's our base formula. Let's now stick in the numbers that we've got. Well, we know that the principal is 100,000, all right? 1 plus what we know, we have to adjust the rate, which is going to be 10% per annum. So it's going to be 0.1 divided by, and it is every, semi-annually. So it's going to be equal to, just let me, don't know why I put a 12 there, okay? And we say it's going to be 2 to the power of 2 times 2.5. My final answer is 127,628.16. Well, hold on. Next question. What if we change it to monthly? That means we're receiving it how many times? We are receiving it 12 times. Therefore, A is going to be equal to 100,000 times 1 plus 0.1 divided by 12. 12 times 2.5 is going to be equal to 128,269.59. And remember, just go back, the 12 and the 12 and the 2 and the 2. This is number of times we add interest. Interest each year. And then we multiply it by the years, right? Because how many times are we going to add interest? Every year we're adding interest once, there twice, there. So we add interest 1, 2, 3, 4. We're adding interest 5 times, which is equal to 2.5 times 2 is 5. We're adding it 5 times. Okay. Oops. Need the next page. Change it back to black one. Okay. All right. Okay. Now interest rates aren't usually fixed. They fluctuate. Remember, let's take a mortgage for a house, all right? The mortgage you take for a house is over a period of sometimes, let's say up to, 25, 30 years, that house, right? So you buy it today and you pay it off every month, don't you? Like that, for the rest of your basically life. But they quote you the interest rate at the beginning. Nobody can say what's going to happen 10 years, let alone 30, let alone even 5, because economies are so changeable, aren't they? They fluctuate all the time. Exogenous shocks come into economies. We get price hikes, we get price drops, we get inflation, deflation. Things happen. It's a dynamic system. What is going to happen? Therefore, generally speaking, interest rates are not fixed. You can get a fixed rate. Okay. Where would you use that? Well, if you're buying a car, for example, you might say, you know what? I've budgeted to pay so much every month, therefore I will fix my rate. The bank will fix the rate, but it will be higher because they'll say, we're not sure, rates might go down, but we'll fix it slightly higher. So you actually pay a premium for a fixed rate. Okay? Think about it if you're a bank. Think if you're loaning it to friends. They say, I'm going to pay you every month, but I don't want it ever to change. You're like, okay, but I've got to charge you a premium for that because the risk is now mine. Okay? Normally we pay the risk, but now you're passing the risk over, aren't you? The risk passes to the bank. Bank, aka financial institution. Let me not just say bank only, but a financial institution. The risk passes to them. So if interest rates go through the roof, they're sitting with their hands in the pockets. They don't know what to do. So they actually price a risk into it. All right. If you're the betting kind, you might say, I think interest rates are going to drop, so I'm not going to fix my rate. I'll fluctuate with the interest rate. So yes, we have to account for this process, don't we? We have to account for the fact that we've got a risk premium that comes into it. Therefore, we're going to have, we're just talking about it at the moment, the next section I'm going to do is I'm just going to do some examples on these rates. All right? What's going to happen? Well, let's say for the first 0, 1, 2 years, I'm going to have an interest rate. But then the interest rate might change. Then the interest rate might go back again. Then the interest rate might go, less. And then the interest rate might go there. So you're going to have interest rate 1, interest rate 2, interest rate 3, and interest rate 4. It changes over, let's say, 4, 5, 8 years. It can change. And we're going to now have a look in the next section how we actually adapt to the changes in the interest rate as they come forward. All right? So we've gone through this effective rate. Remember, always draw the timeline. That's critical. Okay? Cheers. I'll see you in the next one, and we'll deal with variable interest rates. Cheers for now. Bye.